Alright, so today we will be doing the last chapter of O level and IGCSE computer science, which is Boolean logic. Alright, so this is also a very short chapter, however, it does require some attention, so make sure that you are paying attention when you're listening to this. Alright, so first of all, I've already given you an introduction about logic gates in the first chapter. Right now we will study them in detail. So first of all, logic gates are basically just a way to manipulate data, right? So over here we have a simple logic gate which is called the NOT logic gate. All right, so basically when we give a logic gate an input, it will give an output according to the type of input that you give. All right, so over here you can see that this specific gate has only one input. All right, so this is the only logic gate that has only one input, whereas the rest have two inputs. So over here you can see that when we give an input of 0, we get an output of 1, right? And when we give an output of 1, we get an output of, when we give an input of 1, we get an output of 0, right? So this is basically the purpose of the NOT gate. It basically inverts the bits. All right. Also, as I mentioned over here as well, you need to memorize all of the outputs of the logic gates, right? You need to know how each of them works. Now coming down to the AND logic gate, over here you can see that when we give an input of 0 and 0, right? So you can obviously see that we are giving two inputs, right? So the NOT gate was the only one with one input, whereas all the other gates have two inputs. All right, so over here you can see that when we give an input of 0 and 0, we get an output of 0. When we give an input of 0 and 1, we get an output 0. 1 and 0, we also get an output of 0. When we give 1 and 1 as input, we get an output of 1. All right, so AND basically means that both of the conditions have to be true in order for it to give an output of 1. All right, so over here you can see that A is also true, whereas B is also true. Therefore the output is also going to be true. So now we will move on to the OR gate. All right, so over here you can see that when we give an input of 0 and 0, we get an output of 0 as well, right? But when we give an input of 0 and 1, we get an input of 1, and then when we get an input of 1 and 0, we get an output of 1 again, and when we have an input of 1 and 1, we get an output of 1. Alright, so in this OR gate, we basically need to have only one condition as true, and then we will get an output true, right? However, in the AND gate, we see that both of the conditions have to be true in order for it to give an output of true or 1. Alright, so coming down to the NAND gate, this is basically just the inverse of the AND gate. Alright, so over here you can see that we have an output of 1 1 1 and 0, right? However, in the AND gate we get an output of 0 0 0 and 1. Alright, so if both of the conditions are true in this NAND gate, we will get an output of 0, whereas all the other types of inputs, we will get an output of 1. Alright, coming down to the NOR gate, this is also like the NAND gate, however this is the inverse of OR gate, right? So over here we can see that the OR gate gives an output of 0 1 1, right? Whereas over here we get an output of 1 and 0 0. Alright, so basically when both of the conditions are false, we get an output of true. Alright, and then coming down to the XOR gate, this is a little bit interesting as well. So this gate will only give true when only one of the conditions are true. Alright, so if both of the conditions are true or if both of the conditions are false, it will give an output of 0. But if only one of these conditions are true, it will give an output of 1. Alright, so make sure that you differentiate between the XOR gate and OR gate and NOR gate. Alright, this is actually a very simple concept. So when you practice these in your exams and maybe in your past papers, you will find that these questions are very easy. Alright, so let's just come down to logic expressions, logic circuits, problem statements and truth tables. Alright, so these types of questions are very common in your exams, so make sure that you practice a lot of these and also try to understand what I'm going to explain over here. Alright, so first of all, the first type of question that we get is that we are given a few logic gates, right? So over here you can see that we have been given 4 logic gates and we have to write a logic expression for this logic circuit. Alright, so let's do this. First of all, what I want you to do is I want you to identify all of these gates with a number. Alright, I want you to give a certain number to every single gate. Alright, so here you can see that logic gate 1 is not A and logic gate 2 is not C. Alright, so basically when C is being inverted by this NOT gate, we say that the logic gate is basically a not C logic gate. Alright, and then now we come down to a little bit tricky part, which is basically gate 3. Alright, so over here we can see that we are getting two different inputs, alright, from this logic gate and from B. Alright, so we will obviously just write B as it is, alright, and then we will write the input of not A. Alright, so not A and B. Alright, and we will actually join that using the word AND. Alright, so over here you can see that logic gate 3 is basically a combination of logic gate 1 and B, right? Therefore, logic gate 1 was basically just not A and B, and this is how you write a logic expression. Alright, so logic gate 4 is basically a combination of logic gates 3 and 2. Alright, so over here you can see that logic gate 4 is a combination of logic gates 2 and 3, right? So logic gate 3 was basically not A and B, as you can see over here, whereas logic gate 2 is basically not C. Over here you can see that C is actually not C. Alright, so that we will join with OR. Also make sure that you are using brackets over here. Alright, so because this whole logic gate is just one output, alright, if you don't actually add OR, maybe you can join B with OR not C, right? So that will basically result in an error. So make sure that when you are writing such types of expressions, you will use brackets. Alright, so basically when we combine logic gates 3 and 4, we get the answer not A and B in brackets or not C. Alright, so coming down to the second type of question, which is basically completing a truth table. Alright, so what we basically have to do is that we are given a few inputs. So over here you can see that A, B and C are the same as A, B and C over here. Alright, so you will already be given these inputs. Alright, secondly, you will need to write down all of these columns by yourself, including this final answer. Alright, so this final answer as well as these working space columns make up your actual answer. Alright, so this is actually just a truth table for the question above. So let me just show you how you can actually solve this. Alright, so basically 1, 2, 3 is the number of logic gate that I was talking about before. Alright, so let's see what logic gate 1 is. Logic gate 1 was basically not A. Alright, so over here you can see that 1 is basically 4 ones and then 4 zeros, right? Whereas A was basically 4 zeros and 4 ones, right? So when you pass an input through the NOT gate, you basically get the opposite of that input, right? So over here you can see that 0 will basically be getting 1, 0 will be getting 1, and then over here you can see that 1 will be getting 0, 1 will be getting 0, right? So this is basically just an inverse of the column A. Alright, then we have the second logic gate, which is actually not C, right? So over here you can see that the second logic gate is corresponding to this column C, right? So 0 is basically going to be 1, 1 will become 0, 0 will become 1, and so on and so forth. Alright, now let's move on to the third column, which shows us this input. Alright, so we have a not A input along with B, right? So what we basically have to do is that we have to combine the not A part, right? So if you want, you can actually label that by yourself. So this was basically the not A logic gate, right? And obviously we have B over here. Alright, so you have to perform the AND logic gate on these two columns only. Alright, so make sure that you don't actually confuse C or A in this. Alright, so over here you can see that ignoring this part over here, 0 and 1 are basically going to give an output of 0, right? Because for AND to be true, we need to have both of the inputs as 1, right? So over here you can see that where we have 1, we have an input of 1 in column 2, right? And 1 in column B as well, right? So this is basically how you solve these types of questions. All right, so you do the same for this part as well. All right, and this is how you solve this question. And lastly, the fourth logic gate is going to give us the final answer, right? So you don't actually need to create a working space column for that. You will just write down the answer inside this column, right, the final column. So X is basically going to be a combination of this gate and this gate, right, and will perform an OR logic gate on this, right? So the third one and the second one, I believe, yeah, the third and the second one. All right, so you can see here that 1 and 0, right? So for an OR gate to be true, you will only have to have one condition as true, right? So over here you can see that because we have 1 over here, even if we have 0 over here, it will still give us 1, right? Over here you can see that both of them are 0, therefore we get a 0 over here. We have both of them as 1, we get 1 over here, so on and so forth, and this is how you get your final answer. All right, so coming down to the third type of question, which is to draw a logic circuit from a logic expression, right? So before we actually created a logic expression from logic circuits, now we have to draw a logic circuit from this logic expression. All right, so first of all, what I want you to do is that I want you to solve the brackets first. All right, because if you want to start from left to right, over here you can see that when we were actually writing down the expression, we were going from left to right, right? So first we solved the logic gates on the left, right, not A, not C, and then we moved on to the third logic gate, right, not A and B, and then we moved on to the last logic gate, right? So I want you to solve this from left to right as well. All right, so first of all, I want you to draw this logic circuit by starting off with the brackets. So first of all, A NAND B, right? So we take an input from B and we take an input from A and we join it to a logic circuit. So this is a NAND gate, right? And then you can see that this gate over here is a XOR gate, all right? So you can see that in the second column, then in the second bracket, sorry, it is stating that we have a XOR gate, therefore I drew a XOR gate on the left side. All right, and I'm taking the input from B. So if you want to take an input from B, you can just draw a circle over here and then take the line over to the second one. All right, so I drew the XOR gate over here, and then we have to NOT gate this part. All right, so after this XOR gate, I created a NOR gate and then I joined it using this OR. All right, so over here you can see that both of these things are being joined using OR. All right, and because that is being joined using OR, we will obviously use an OR gate. All right, so that is basically how you solve these types of questions. So coming down to, I believe, the last type of question, which is to write down the logic expression representing the table below. So this is actually very easy. All right, all you have to do is you have to pay attention to the rows that have 1 as the output. All right, and then for, let's just suppose that over here you can see that we have 0 as B and then 0 in B as well, 0 in A, 0 in B, and 0 in C, right? So over here you can see that the first bracket shows not A and then not B and not C, right? So this is all that you have to do. All right, and then you have to join all of these outputs using an OR, right? So over here you can see that the second one in the X column is basically consisting of A and not B, right? So when we have 0, we say not B, and if we have 1 over here, we can see just B. All right, so A and not B and C, and it is joined with an OR again. All right, so also make sure that you're using brackets. All right, so actually this is the last type of question. So over here we are basically given a simple table, all right, and it basically tells us a few things about each of these switches and sensors and what their state will basically be giving an output of 1 or 0. All right, so what state they have to be in order to give an output of 0 or 1. All right, so over here you can see that if the switch is on, it will give an output of 1, and if it is off, it will give an output of 0, right? And for the pressure sensors, if they are greater than or equal to 3, they will give an output of 1, but if they're not, they will give an output of 0. All right, so let's study how we actually have to create this logic circuit. All right, so basically what I want you to focus on is this specific statement that will be given in the question. All right, so first of all, you can see that the switch S1 is on and either P1 is less than 3 or P2 is less than 3 but not both, right? So basically we have to create a logic circuit that will produce an output of 1 when the switch is on and either P1 is less than 3 or P2 is less than 3. Alright, so first of all what I want you to do is I want you to see the word that is joining both of these sentences, right, which in this case is and I want you to write that down, make that gate on the right hand side, alright, because this will basically be the last logic gate that we will use. Alright, so I want you to write down this logic gate on the right hand side. So over here what I want you to do is I want you to create this and then I want you to make this logic gate and then I want you to connect all of the other things that we will do later on, right, because this will actually help you secure these few marks first. Alright, then we will secure the rest of the marks. Alright, so basically we have to create an output of 1, alright, and we are using an AND gate. So when does an AND gate actually produce an output of 1? When both of its inputs are 1, alright. So first of all we need an output of 1 from this side, alright, so the switch 1 is on. So over here we can see that when the switch 1 is on, it is giving an output of 1, right? So we don't need to add any logic gates over here, we can just simply connect it to the AND gate as you can see over here as well, right? However, over here you can see that for the second type of input to be 1, we need to either have P1 to be less than 3 or P2 to be less than 3 but not both, alright. So there is only one type of logic gate in which only either of those inputs have to be 1 in order for it to give an output of 1, right? So that is basically the XOR gate, right? So the XOR gate is basically going to be used over here because this is the only logic gate in which either of those inputs have to be 1, but if both of them are 1 it turns off, and if both of them are off it still gives an output 0. Alright, so once we've actually identified the gate that we'll use, we will just simply connect these P1 and P2 over here. Alright, we'll connect P1 and P2 to this XOR gate and we'll connect that XOR gate to the AND gate. Alright, so once you actually build this logic gate, I want you to go through this whole thing by yourself, alright, and I want you to get an output of 1. Alright, so basically we need an output of 1 when switch 1 is on. Alright, so the switch 1 is on, alright, and it gives an output of 1, therefore we get an input of 1 over here. Alright, so far so good. Secondly, over here we can see that either P1 is less than 3 or P2 is less than 3 but not both. Alright, so when P1, let's just take the first scenario where P1 is less than 3 but P2 is greater than 3. Alright, so when P1 is less than 3 it is giving an output of 0, and when P2 is greater than 3 it will give an output of 1. Alright, so basically this is what we will be getting from P1 and P2, right? So P1 will give 0, P2 will give 1. So when we get two different inputs for XOR gate, this will basically give an output of 1. Alright, so when you get an output of 1 and 1, we will get the final output 1 as well, and therefore this means that we actually solve this question the right way. Alright, and yeah, this is pretty much it. Over here you can see that I have given a few tips as well, so make sure that when you're going through my notes you actually look through this. Alright, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. Also make sure that you share these with your other friends who are studying the same subject. Alright, I'll see you later.